Alright, hello everyone. So today I wanted to go over the notes that we took on Tuesday, August 10th. And that was just a review of our one-step and two-step equations. I'm not going to go through every single example here because we didn't in class, but just a few so that we kind of remember and get the gist of what's going on here. And you can find this sheet on Teams in our files. All right, so one-step equations is going to come first. Alrighty, so one-step equations take one step to solve. Solving means that you found what x is equal to. So to do that, you're going to use inverse operations to find what your variable is equal to. And by inverse operations, I mean opposites. So if we had a number that was being added, the opposite would be subtracting, and vice versa. Or if we had a number that was being multiplied, the opposite would be division, and vice versa as well. So these are our opposites here. So let's take a look at what we have and start solving. So let's start with number 1. We have m plus 12 equals 10. So to find my m, we want to do the opposite operation on this number here. We're doing it on this 12 because it's on the same side as our variable, and by sides, I mean the two different sides of this equal sign. So, like I said, we're doing inverse operations to find our variable. So, inverse, I see we have a plus sign here. The opposite of adding is subtracting. So I'm going to subtract 12 from both sides. All right, so when we follow through with that step, we have m. M didn't get touched at all, nothing happened to it. We have 12 minus 12. Well, that's 0, but we don't need to write that down, so we're not going to. I am going to cross these out just so that we can show that they are used, that we got rid of it from that side. Then we have our equal sign, and then we have 10 minus 12. Okay, so 10 minus 12, that's going to be negative 2. And now I have my answer. M equals negative 2. Okay, so that was one step. That one step was subtraction. So let's keep going. Let's do number 2. All right, we have negative 2 equals g minus 9. Okay, I'm going to draw that line again to show the two different sides. I want to get rid of all the numbers on the same side as my variable g. So that means this negative 9 or minus 9 needs to go. So to do that, we're going to do our opposite operation. Since this is being subtracted, I'm going to add. So I'm going to add that same number, 9. But whatever you do to one side, you have to do to the other. And then follow through with that. So we have negative 2 plus 9. That's going to be a positive 7. Our equal sign, g. And then negative 9 plus 9 would be 0. But once again, we don't need to write that down. So I'm just going to cross these out to show that they are eliminated, that they've been canceled out. It's probably something you've heard before. All right, so now we know 7 equals g. We know what g is equal to. So that was it. Our one step was adding. All right, let's take a look at the next one, number 3. So we have negative 7y equals negative 91. Okay, so here we don't see any signs. Like, I don't know exactly what operation is happening here because there's nothing between these two. But something to keep in mind, when something looks like this, when we have a number and a variable, that means these two are being multiplied together. So the opposite of multiplying is going to be dividing. So we're going to divide by -7 on both sides. Remember, those sides are separated by the equal sign. So when I divide -7y by -7, that's going to leave me with a 1y. Remember, any number divided by itself is equal to 1. But I don't need to write that 1, so I'm just going to leave that out. All right. We can also cross those out just to be sure that we showed we used those already, or that we got rid of them. All right, so now we need -91 divided by -7. If you don't know that off the top of your head, that's okay. You can use a calculator, and you'll find that it's 13. So y equals 13. The one step we did was division. Okay, let's take a look at another one. All right, we have a over 9 equals -4. All right, so I know this one looks a little scary because of this fraction sign. But something to remember, that fraction sign can also be used as a division symbol. So this means a divided by 9. Okay, so the opposite of division is going to be multiplication. So we're going to multiply by 9 on both sides. Now when we do that, these two will become a 1. But remember, like in that last example, we don't need to write the 1. So we're just going to leave it as a equals -4 times 9. All right, so that's going to be -36. And that's it. A equals -36. That was one step, and that step was multiplication. Cool. So that's just kind of a general overview of one-step equations. So let's take a look at the next section here. This is going to be fractions, or specifically how to get rid of fractions when you have them in a one-step equation. To get rid of a fraction, multiply by the reciprocal. The reciprocal is just going to be the flipped, oops, goodness gracious, what happened? All right. The reciprocal is going to be the flipped version of the fraction. So you're just going to multiply by that flipped version, and they will turn into a 1. So let's take a look at the first one, number 5. So we have 2/3 x equals 10. All right, so our goal is to get rid of this fraction here. Like we said, to get rid of a fraction, you're going to multiply by the reciprocal, or the flipped version of the fraction. So for us, that's going to be 3/2. Now when that happens, these threes will go to 1, and so will these 2's. So that's going to leave us with 1x, but like we said before, we don't need to write in that 1. So we're going to have x equals, but remember, whatever you do to one side of your equation, we multiplied by 3/2, we have to do to the other side. So let's multiply. We got 3/2 multiplied by 10. Okay, so we had a whole number multiplied by a fraction. So let's just make that whole number into a fraction. Remember, any whole number has the denominator of 1, because any number divided by 1 is just going to be itself. So we can do that to any whole number, and it's not going to change anything. Then from here, it'll be a little bit easier, and we could just multiply straight across. So we're going to do 10 times 3, that's 30, over 1 times 2, that is 2. Okay, now we got to simplify. Remember what we said before. This this fraction sign is the same as the division symbol. So let's divide 30 by 2. That is going to be 15. Therefore, x is going to be equal to 15. Now, I know that was kind of a lot, but that was actually only one step. So let's do one more of these just so that we can see what's going on here. So let's do number 7 now. So we got negative 6 over 5k equals 12. Alrighty, so we're going to multiply by our reciprocal. That's going to be 5 over 6. Something to keep in mind, though, we need to keep that negative sign. We're only changing the signs if we are adding or subtracting. If we're multiplying or dividing, we need to keep that sign, or else we'll end up with a negative x, or a negative k in our situation. Alrighty, so we got a 1 here and a 1 here, so that's going to leave us with a 1k, but we don't need to write that 1. That's going to equal 12, but remember, 12 times negative 5 over 6. Because whatever you do to one side, you have to do to the other side. So let's just do like we did before. We're going to put this 12 over 1. And then multiply straight across. So we have 12 times 5, or negative 5. We know that's going to be negative 60. And then 1 times 6 is going to be 6. Then we're going to divide, and we have negative 60 divided by 6. That's going to be negative 10 for us. And that's that one. K equals negative 10. Okay, so I know fractions are a little tricky for us, but don't worry. They're not going to be huge, especially not on this first quiz. So no worries about that. I just wanted to make sure that you had this information for the future, because we're definitely going to run across some that do have fractions, just not a lot. All right. That was one-step equations. So I'm going to cut it off here. And in the next video, we're going to do two-step equations.